The purpose of this video is to explain how to lay out an electrical resistivity survey using a GF Instruments ARES 2 electrical resistivity meter. We will not be discussing the theory of electrical resistivity method. Warning: during the measurement, there is a high voltage on the electrodes. The instrument is to be operated only by responsible and qualified users that understand how the equipment functions. In the case of an emergency, any person can press the red main switch on the control box to power down the unit. The first step in field collection is to determine the basic field parameters of your survey. Line length dictates your depth of penetration, and the spacing of electrodes controls your data resolution. Increasing both of these parameters increases the number of data points that the system will need to acquire, which will increase the measurement time. When designing an electrical imaging survey, desired depth of investigation, anticipated resolution, and available time must be balanced to choose your survey parameters. There are a few different models of the GF cables. We will be using the passive multi-clectrode cables with switch boxes for this demonstration. Other versions of these cables come in a cylinder version as active cables. We prefer the passive cables with the switch boxes because they are lighter and easier to work with. The GF cables have 8 outlets, spaced 5.5 meters apart. GF Instruments also provides marine cables and cables with measurement adapters for 1D methods. After observing your site and determining the best location to collect your data, extend a tape measure along the path where you want to collect. In this example, we are collecting a survey with electrodes spaced 2 meters apart and are using a 3-cable array. Therefore, our total profile length will be 46 meters. If you only have access to 3 cables but wanted to acquire a longer length of profile, you can acquire a roll-along survey. In a roll-along survey, you enter the total desired profile length at the start of the survey. The ARES unit will recognize that the total length is greater than what is connected and will prompt you at the end of the initial survey to move the electrodes. In a roll-along survey, it is optimal to move as many electrodes as possible at a given time without omitting data coverage. Hammer the electrodes into the ground as deep as possible while leaving enough to connect the electrodes at the top. Maximizing contact between the ground and the electrode is the first step to acquiring good quality data. Lay the cables out with the male end at the zero end and connect the multi-electrode outlet to the steel electrode using a rubber O-ring or rubber band. We tape our electrodes so that they are easy to see in the field. It is very important not to have anything between the outlet and the electrode. Every female end of a cable needs a switch box, including the last cable of the profile. If you're using the active cylinder version of the cables, no switch boxes are necessary. Determine which junction along your array to connect the control unit to. It can be in the middle or the end of the profile. If rolling along, to minimize moving the control unit, it is best to connect the control unit at the end. Using the T-piece, attach the cables to the proper ends and connect the longest connector to the box. Be sure the female end of the passive cable between the T-splitter and the cable has a switch box. Connect the unit to a power supply, a 12-volt lead car battery, or the DC converter from GF Instruments. Your survey line is set up and you are now ready to acquire data. Before picking up your array, remember to record the topography and location of your line with a GPS if needed. THG Geophysics is the US representative for GF Instruments. Please contact us directly for more detailed equipment information and pricing options at www.thggeophysics.com.